Today we're going to be talking about 3.1 systems of linear equations. A system of linear equations is a set of two or more equations, and we'll be graphing these to determine their solution. All right, so the point of intersection is called the solution. If you have two lines, the point of intersection will be an ordered pair. So you have three possible scenarios. The first one is infinitely many solutions. That means, and I'm not sure if you can see it really well, there's a pink line and a blue line. They lay on top of each other because they are the same exact line. So they would have the same exact slope and they would have the same y-intercept, okay? So that would mean infinitely many solutions because all the solutions on this line would work for both equations. The second scenario you could have is no solutions, where you have parallel lines. Parallel lines have the same slope. So these two lines are going to be equations with the same slope exactly, but notice it crosses at the y here and it crosses at the y there. So they will have different y-intercepts. The last scenario you might have is one solution, which is going to make an intersection. And that means that they are going to cross and intersect right at this point right here, and that is the solution that works. Now remember, we're talking about an ordered pair, which gives you an x and a y. So that x value and that y value will work for both equations. Notice that we are going to have different slopes. One of these is positive, one of these is negative. You'll have different slopes when you have a one solution problem. So that'll distinguish it right away from the other two. All right, so what did you notice about the slopes of each scenario? Again, the one that has infinitely many solutions, same slope. The one that is parallel, same slope. But the one that has one solution, different slopes. What you notice about the y-intercepts? Well, over here with the infinitely many, they had the same y-intercepts because it's the same line. Over here, they had different y-intercepts, but they had the same slope. And here, they could have similar y-intercepts depending on where it crosses. Okay? If it crossed right there, it would have a y-intercept that would be the same. But if it's moved over to the side, it won't. Okay? So when finding solutions to systems of equations, you need to solve the equation for y. Put in y equals or y equals mx plus b. All right. You should be able to tell how many solutions a linear system has by that slope. Again, we talked about just a second ago. So in my example right here, I have y is equal to 2x plus 1. And the other one is y equals 2x minus 3. All right, so you notice your slope, okay, it's going to be the same. The slope is 2 and the slope is 2. So that means that they have to have either infinitely many solutions or no solutions, depending on where they cross on the y. Well, then you look at your y-intercept. This one crosses at 1. This one crosses at negative 3. So that means they are not the same line, so these are parallel. Okay, parallel. All right, so that means that they will have no solution. They will never meet. Okay? So parallel lines have no solutions. All right, so again, how can you tell if they have the same slope, how many solutions? You look at the y-intercept. Look at y-intercept. Again, y-intercept is where it crosses the y. If the equations do not have the same slope, then the system will only have one solution. We just talked about that. Great. Find the solution to the system of equation that we've given here. This one says y is equal to x plus 2 and y is equal to 3x minus 2. Now, in order to graph anything, you have to have it in y equals. Well, it happens to be that this example, both of them are in y equals. So we can start at y equals x plus 2. That's that parent graph of x shifted up 2. So we start right here at 2. Slope is 1. So this is going to be right through here. Okay, change colors. And then we're going to graph this one. This one is 3x minus 2. We just finished talking about all these shifts. This one is shifted down 2 from a parent graph of y equals x, down 2 in a stretch of 3. So down 2, what you got, stretch of 3, 1, 2, 3 and over 1, 1, 2, 3 and over 1, 1, 2, 3 and over 1. And draw your line. All right, so you notice they intersect right here. And so you look at that ordered pair, it goes from x is 2, and it goes 1, 2, 3, 4. So the ordered pair, the solution, is 2, 4. And these are written in ordered pairs, so they need to be written with the parentheses. You cannot just write 2, 4. It needs to be an ordered pair. All right, so that takes care of a linear one. Now we have systems of nonlinear equations, and you could have 1, 2, or none solutions. So that would be, for instance, I'll give you one. Y is equal to x squared, the first line, and then the other one could be, so let me graph that, that's going to be right here, starting right here. And we're making a U. Looks kind of pointed, like that. Go off. Okay, and then we could have a y is equal to, let's see, negative 2x plus 4. Okay, so I'm going to graph that one. That one is a shift down, shift up at 4. Well, let's make that a negative 4. Let's make that a negative 4. Okay, so it's going to go down 2, 3, 4. 1, 2, 3, 4. And backward shift. Okay, so this one is going to be a straight line through here. Here's a different color. And it's going to go right through here. Like that. And you're going to see it's going to intersect right there. So this would be a 1 solution. Right? Then you could have y equals x squared again. You could have y equals negative x squared plus 4. Okay? Let's try that one. I was going to graph right through here. And you have to do that from our previous lessons on parent graphs. And this one is going to be a reflection because it's a negative in front of that, and it's going to go up 4. So it's going to start 1, 2, 3, 4, and it's going to go down this way. Okay, so as you can tell, the intersecting points of these two graphs, there are 2. Right where those 2 graphs meet are intersections. So this is a 2 solution. Okay, 2 solutions. And then the last one would be, I'm starting to y is equal to y, you can tell it happens to me when I'm trying to record. Y is equal to x squared. Okay, and the other one we're going to say is y is equal to negative 4. And you can tell there is no solution, it never meets, so this is a no solution situation. Okay? So we have a line in a parabola that intersects only once. Then we have two parabolas that could intersect twice, one right here, one right here. And then we can have a parabola and a line, and they never intersect at all, and that's a no solution. Okay. All right, so let's find the solutions of these graphs. Y is equal to 3x squared minus 1, and then 3x minus y equals 1. Well, one of those is already solved for y. We need to get the other one ready for that. So let's go ahead and fix this problem right here and solve for y. So we're going to be having a negative y equals negative 3x plus 1 when we move 3x over. And then because of this negative, we have to change all our signs. So it's going to be y is equal to 3x minus 1. So this is what we're going to graph, and this is what we're going to graph. All right, so let's do the first one, this one right here, 3x minus 1. So it's going to be a shift down and a stretch of 3. 1, 2, 3 over 1. 1, 2, 3 over 1. And graph that line. Then you're going to do this one. Well, this one is a parabola, and we know that because there is an x squared right here. So we know that shape is a parent graph. It's going to be a U. It's being shifted down 1. So let's start right here. Shift it down 1. Down 1. And this one's going to have a stretch of 3. So we're going to go up 1, 2, 3 over 1. 1, 2, 3 over 1. This parabola is going to be right in here. Right in here. Right. Right in here. Okay? So if we graph that, we know it's going to intersect right here. And it looks like we're going to intersect that right here. That would be a two-solution. Okay? If I graph that appropriately, it looks kind of funky like this. But it should be two solutions. All right, the next one is going to be an absolute value graph. How we know that is because of these absolute value bars. And we know that shape is a V shape. We also know how to graph these because we've learned all the transformations. So this one is going to be shifted up 1 because of the plus 1 on the outside. So it's going to be shifted up 1. And then it's going to go to the right 3. So up 1 and shift it to the right 3, and that's where we start. All right, so that has a slope of 1. And then the other one is now shifted up 1, but it is moved to the right 5. So this is still up 1, but we're going to go over 2 places instead. We're going to do our up 1 over 1. And here's my second line or graph. So you can see they intersect right here. So this is a 1 solution. Okay, 1 solution. All right. All right, so there's additional practice problems that you're going to be doing in classwork. I hope this helped you with all the graphing and understanding how to do the beginning of systems of linear and nonlinear equations. See you in class.